Hey everybody, it's Dr. J, and today we are talking about chemical equations. Let's talk about chemistry. So let's look at an example, right? When we're going to balance our chemical equations. So we have methane gas burning to produce carbon dioxide and water. Okay, so we have our equation here, right? Equation as I mentioned before. So with conservation of mass, we understand that we're going to have the same amount of grams as we do in our reactant side, as well as in our product side. Now, because of this conservation of mass, with all our chemical equations, we're always going to have to balance them out. All right, so that's the reason why going forward, every single chemical equation you have, you need to balance your equation because now you know. Right now, you know that if your equation is not balanced, well, technically that's not right, right? Because of conservation of mass. All right, so if we balance the equation, we're going to have equal amounts of elements on both sides. So beforehand, right, this is our equation I've been showing you, right? How it just looks normal. CH4 plus O2 gives me CO2 and H2O. Notice, is anything balanced right now? No. I have two oxygens on my reactant side, but I have three oxygens on my product side, right? I got four oxygens on my reactant side. I have two on my product side, right? I got one carbon here and I have one carbon there. That's the only thing that's balanced right now. So going forward, we need to make sure we're going to balance our chemical equations. Now, how are we balancing our chemical equations, Dr. J? By using coefficients, right? So bam, let me throw a 2 in front of this O2, and let me throw a 2 in front of this H2O, and what's going to happen here? Now with my oxygens, I have 4 oxygens in total, right? 2 times this 2 here is 4. And then I have 2 oxygens plus another 2 oxygens here. Because remember, this 2 is letting me know I got 2 moles of that. So I got 2 waters, right? I got 2 phones, all right? I got shout out to 2 chains, all right? I got 2 of those. As well as, if we look over here, what happens with my hydrogens that wasn't balanced before? Now, I had 2 before, but if I multiply by 2 because of the coefficient, I have 4 hydrogens, right? And if I look on this side, I have 4 hydrogens. So let's talk about balancing chemical equations. Here are the basic steps for balancing all of your chemical equations, okay? You're going to count your atoms of each element. You're going to pick an element to balance. So I recommend usually the most complex of them all. So a complex compound. 3, you're going to find the least common multiple, right, and factors to make both sides equal. I'll show you guys this in a bit. And then with that factor, you're going to use that factor as a coefficient, which is that number in front of the formula. And then you're going to recount and repeat it until everything is balanced. So let's look at under 1,000 degrees Celsius, right? I got ammonia gas reacting with oxygen gas to produce gaseous nitrogen monoxide and gaseous water. First thing we need to do is let's put all this in words, right? Ammonia gas plus oxygen gas gives me nitrogen monoxide gas and water gas. Now I can translate these words to the chemical formula. NH3 gas, oxygen, O2 gas, nitrogen monoxide, and O gas, H2O gas. So now we have our equation as formulas. From here, we need to count the number of elements on each side. So let's just look at everything, right? Let's look at all our elements. I got nitrogen, I got hydrogens, and I have oxygens. All right. And if I look on my reactant side, I got 1 nitrogen. On my product side, I got 1 nitrogen. Okay, cool, it's balanced. But let's look at our hydrogens. I have 3 hydrogens on my reactant side. I have 2 hydrogens on my product side. Not balanced. Let's look at my oxygen over here. I got 2 on my reactant side, and then I have 1 oxygen in my NO, and then I got 1 oxygen in my H2O. So I have 2 there. So the only thing that's not balanced is my hydrogen. So let's balance some stuff, all right? Let's look at the next step. Find the least common multiple and factors to make both sides equal. So what are we going to do here? In this case, we have our elements already kind of set for us, right? We understand that I got 1 nitrogen on this side, 1 on this side, 3 hydrogens on this side, 2 on that side, 2 oxygens right here, 2 oxygens right there, right? We understand this. But what is my least common multiple that I'm trying to balance? So in this case, let's balance the hydrogens, right? Since they're not balanced. So 3 and 2, right? 3 and 2. What is the least common multiple between 3 and 2? Right? We got to go back to those math classes, right? 3 and 2. That's 6, right? I need 6 because 2 times 3 is 6. That's the lowest one. And 3 times 2 is 6. That's my lowest one between the two. So 6 is our least common multiple that we have in common. So because of that, right, in order for me to get to 6, I need to multiply my 3 by 2. In order for my 2 to get to 6, I need to multiply that by 3. All right? So now that I know what factors I'm going to use in order to make them equal, let's look down here. So the next step says to use factor as a coefficient. So the number in front of the formula, right? So like I mentioned, in order to get to 6, I got to multiply by 2. In order to get to 6 on this side, from my product side, I got to multiply it by 3. So with these factors, I'm going to use as coefficients. So right now, if I look, my 3 hydrogens are in my NH3. So I'm going to multiply, right, this being my coefficient by 2 now. So now 2 times the 3 hydrogens here, I have 6 total hydrogens. If I look on this side, my hydrogens were in my water. If I multiply by the factor, now I have, instead of 2 hydrogens, I have 6 hydrogens, right? 3 times 2. So once I do that, now let's recount. 2NH3 plus O2 gives me NO and 3H2O. So how many nitrogens do I have now? 2 nitrogens. All right, cool. What about my product side? Oh no, now I have 1 nitrogen. So what we're going to see here is that as we are rearranging, trying to balance things out, other things might change, and that's okay. We're going to just have to readjust. But let's look at our hydrogens, right? Well, I have 2 moles of NH3, so 2 times this number here, 3, that's 6 hydrogens. So we're good there. What about on this side? 3 times H2, right? The 2 here, I got 6 hydrogens. Good there. But what about my oxygens? I still have 2 on this side on my reactants, but what about products? Well, I have 1 for my NO, but now that I have this 3 in front of my coefficient, I no longer just have 1 oxygen. I actually have 3 oxygens because there's 3 moles of H2O. So that's 3 plus 1. Well, we have a total of 4 now. So because of this, we're going to have to repeat the process, all right? So the same thing here. What do I want to balance next? I want to balance my nitrogens, right? So if I balance my nitrogens, I got 2 on this side. What's the least common multiple between 2 and 1? 2, right? 2. So, right, I can leave this alone, right, because I have 2, but I have to use a factor of 2, in this case, multiply by 2, in order to get my least common multiple. So now I do 1 times 2, all right. Now I'm going to put my 2 here as my coefficient. And then let's recount. So now I have 2 nitrogens, bam, and I have 2 nitrogens here, bam. My hydrogens still stay the same at 6 and 6 on both sides from the 2 here. And then 3 times 2 here. And then let's look at oxygen, right? Now my oxygens have changed, right? I have 2 still on this side, but now since I added this 2 as my coefficient, I now have 2 oxygens plus the other 3 from before. So how are we going to balance this out? I had to go over to the board to let y'all know. All right, so we have 2 NH3. This is plus O2 gives me 2 NO and 3 water, right? So we know that we have right now 2 nitrogens on this side, 2 nitrogens over here, 6 hydrogens here, 6 hydrogens here. But let's look at our oxygens. We have 2 oxygens here, 2 oxygens here, 3 oxygens here. So our oxygens right now, we're looking at 2 and 5. So we need to figure out a way to balance our oxygens, okay? So in this case, what do they have in common? Well, they're going to have 10 in common, right? For our least common multiple. Now, how are we going to go about, right, balancing this equation here? So, like I mentioned, 10 in common. So in this case, the only oxygens on this side, we're going to put a 5 here. But what about this side, right? It's a little bit complicated because we got our oxygen split up. Basically, what's happening here is if we times that by 2, we're doubling everything, right? So you double everything. This is going to be from 4. This becomes 6. Now, we need to make sure that we recount, right? We got to recount. So now let's look at our oxygens. I got 5 times 2. That's 10. And what about this one? 4, because we just doubled everything. So 4 plus 6, well, that's going to be 10. But what about everything else, right? We got to double check to make sure everything's balanced. Our nitrogens, and then we got to look at our hydrogens. So nitrogen, we have 2, but now I have 4 nitrogens. So how am I going to balance this out now? Well, let's just double, right? To where we have 4 nitrogens, 4 nitrogens. So now we got 4. So what about our hydrogens now that we've balanced our nitrogens, right? Because our oxygen's still the same. 5 times 2, that's 10. Then in this case, oxygens, we looking at 4 plus 6, that's still 10. Nitrogens, we just changed, and then our hydrogens, since we doubled this, our hydrogens is now 4 times 3, 12. But what about this side, right, with our hydrogens? Well, 6 times 2, right, we got 12 oxygens. So our final balance equation is 4 NH3 plus 5 O2 gives me 4 NO plus 6 H2O. And this is how we should go and balance our equations, right? We're basically doing the same process over and over again.